Hey y'all, I'm Joseph here with Fun, and I'm at the FRC PCH Gwinnett event with 1683, the Techno Titans out of Johns Creek, Georgia. They've been absolutely killing it here at this event, and they're here to walk us through their pivoting elevator mechanism and amazing deep climb.
Today we're here with Edward, Max, and Alex, and they're going to walk us through our robot. Do you want to start us off, Edward?
Yeah, okay, so I guess starting off with the drivetrain basics, we're running swerve drive with Mark IV eyes from Swerve Drive Specialties on L2 gear ratios, right? We have all of our electrical mounted underneath here, if you can see, right? So on here and here, that's where all of our electrical is mounted, and these Lexan panels here help avoid coral from getting into the robot. We also have this bumper material attached from our elevator to this front panel in order to stop it from getting stuck in there, because we had one match in our previous competition where we were kind of disabled because the coral got stuck in there. Moving on to our pivoting elevator system, if you come around back here, you'll see the actual motor and the gear system. So this one Kraken X60 is running the entire pivoting system, and this is on a 324-to-1, which is 36 here on the max planetaries and a 9-to-1 on the sector gear, which is how it actually rotates. The entire elevator is on a dead axle system, and if you look over here, we have a little kickstand here to help us set our initial position for starting the match. And we'll kind of see in a second if you want to enable that. When you actually enable it, the elevator lifts up a little and that rubber band helps pull it out of the way.
Yeah, so our elevator here is a continuous elevator. It's about 41 inches long and it extends in about half a second to 71 inches. Mainly right here, it's powered by two Kraken X60s to an aluminum drum here, and it runs through a continuous rigging system. So all of the pulleys and string runs are fully custom, and this whole system is tensioned by a single ratchet plate right here. We use West Coast Products elevator bearing blocks right here, these inline blocks, and these have been really good for tensioning and ensuring that our stages don't pop out. If we come around to the back here, the whole elevator is kind of held together by these two tubes, and this allows us to kind of adjust the tension or like the friction in the system on the fly. So if we have too much friction in the system in the center, we can, for example, loosen these bolts or these outer bolts to ensure that we have smooth motion throughout the whole system. In the center here, we have our wrist gearbox for our intake right here. We have one minion on the front that runs at a 60-to-1 ratio, and this runs a chain run here, which is tensioned by this bearing right here, up here to this second dead axle pivot. So this pivot is very similar to this one, and this turns our entire intake. Let's see, intake. And up here we have a 3D printed hub in the center, and this runs to a 1-to-1 through-bore encoder, which gives us really accurate readings off of both our dead axle pivots. So we have a similar system on both. Moving on to our intake, go ahead and enable. Moving on to our intake, we have a singular motor here, a Kraken X44 that runs both our algae and coral scoring systems. Right here in the front, we have two axles, mainly G's or just green compliant wheels. So let's enable. So we line up to the coral station right up at the front, and we drop in a single coral vertically in. One of the really neat systems about this is that it's very wide, so we can cover almost 2 or 3 slots of the coral station really comfortably without having to worry about lineup. On the side here, we have a CTRU can range. So essentially what this allows us to do is that as we put in the coral anywhere here, we can measure that position, and that allows us to offset our auto align points to match up with the reef there.
So I'm really loving your whole pivoting elevator design. How did you guys come up with that decision when you guys were coming up with designing your robot?
So right at the beginning of the season, we saw that the RP for a barge would be 14 points, which is essentially 1 deep climb plus 1 park. And obviously park is relatively simple to do. So we wanted to ensure that we could get that RP reasonably consistently by doing a deep climb. One of our favorite concepts that we saw was unqualified quokkas right at the beginning, where they had a similar system, where it's essentially a pivoting elevator that would lift the whole robot up. We also knew that this is a system we'd be familiar with, especially since last year we did a very similar dead axle system around a whole kind of pivoting superstructure.
Nice.
So we decided to go with that. Let's talk about algae. So right in the back. Yep. So right in the back. So the whole system here is still controlled by this singular Kraken. We have a double-sided belt for our coral, and on the other side we have a single-sided belt for our algae. We use the same rollers for coral as we do for algae, and in the back we have a third polycarbonate kind of tube roller that really lightens up the intake and also provides really effective grip with cat stump tape.
Impressive packaging. Impressive packaging.
Yes. So our deep climb system is essentially really simple. It's very inspired by everybot's deep climb design. Right here we have this passive system, which is powered by essentially just 2 rubber bands, and as the cage falls in, it goes into these slots, and these pull in and back out. So this kind of makes sure that our robot is completely locked onto the cage and there's no kind of risk of falling out again. As the robot grabs on, obviously it will fall down to the ground. And what we've added here is a singular foot here, which the bottom of the cage rests on this kind of old swerve tread, kind of ensure that the robot stays off the ground long enough to get that deep climb. All right, Max, do you want to talk about programming?
Yeah, so this year our programming is sort of just built off of what we had last year. We really wanted to continue the system we began with last year. Last year was the first year we used Advantage Kit extensively to allow for replaying of our code, and this has been really useful throughout the season to be able to just sort of detect bugs whenever the robot might be taken up by mechanical or electrical. Some of the autonomous stuff we do throughout the match is we constantly fuse vision in to our swerve pose estimator, and this makes sure that our wheel odometry just gets updated and make sure that we account for any slippage that might happen. And so we also use like autonomous functions during teleop 2. One of those things is sort of alignment during teleop for the driver. They just have to press one button, sort of pick left or right and what height they want, and it'll automatically just drive forward and score high. And we sort of changed this from our first competition. We noticed how OP Robotics does it, where they sort of drive straight and they preemptively like put up their superstructure to score. And we modified that for this competition, and we did notice like quite a bit of a speed up when we're going to score onto the reef. Yeah, we also have a like custom dashboard we made here. We began using it in 2023. We noticed that a lot of the other just default smart dashboard or shuffleboard, they use up a lot of system resources, and we just wanted something that would just be lightweight and you can just select your autos, because we believe that just the driver should be focusing on the field at all times rather than looking at a screen.
Yeah, so most of our robot here is actually CNC'd. So last year we were able to procure an Omeo X60. No, Omeo, what's it called? X8 CNC. So many of the parts you see here are CNC'd, including the tubes, and this allows us to really massively speed up fabrication, as we can simply just load a 2x1 or a piece of sheet metal into the CNC and essentially just get it done really quickly without any kind of human work. The majority of our parts here are printed using glass reinforced nylon. So we've brought almost spares of every part there. You want to film it, but we brought spares of almost every part in our robot, from the drivetrain all the way to the intake. And this really means that if any part does for some reason snap, that we have a replacement. And furthermore, we brought our 3D printer with us, and that really allows us to print any sort of new custom part if we have some sort of emergency. And throughout, that means that the fabrication of this robot came along much, much faster than we were in previous years.
Thank you so much to 1683 Techno Titans. We wish you luck in this Gwinnett event, and have a great day.